I have all kinds of stuff for us. We are getting kind of to like the end of our Zoom lectures. In fact, next week we will not have lecture. I need a chance to get a few things loaded up, and then I have a meeting on Thursday as well. We will come back for the following week, and I'll put it in the announcements and everything. We'll come back for week 9, and then I'll be able to show you all the snap-on materials. But I kind of set up the class so the first half we were working off of like whatever multimeter you had, whether it was a cheapo or a snap-on or a fluke. Get everything you can out of it, and also teach you a little bit about different electrical circuits as well, right? And show you some different ways with these case studies that you could use your meter to do diagnostics, okay? The second half of the class will be kind of more on autopilot, because you'll be able to view all the class session videos kind of come as you go. So you don't have to go week by week. You could sit down and do them all at once. But the second half is really focused on the specific snap-on 596 multimeter and all the different features of that. And I've set up the points in our class, so if you're like, man, I don't care about that snap-on meter, you really could skip doing those activities and still ace the class. Or you could do those, you kind of pick like what assignments do you want to do to get the points to pass the class. You need, I want to say 250 points is what I added it up to. So it's kind of like however you guys want to do it. But the second half of the class will be all about using this meter. I would say if you haven't gone through electrical class and really used meters a lot, it would be worth your while. Obviously, if you're going to be shopping for a really nice multimeter, like a high-end one, it would be good to give you some comparisons. So there is good information there, and then it's all using Snap-on's presentations and PowerPoint and stuff. But tonight, what we're going to do is we're going to kind of wrap things up as far as the diagnostics. I got 2 diagnostic case studies for you. Or actually 1 diagnostic case study and then 1 advanced meter usage presentation. But before I jump into that, I need to talk to you about next semester. Okay, so yeah, so spring 2021 is not up there. Okay, that's why I wanted to load up the curriculum for you. This is the deal. The college came forth, even though we've been like in an intense negotiations to try to get them to start doing hands-on classes, they're not ready to make that commitment. It's my hope that we'll be able to start hands-on classes, make it maybe second 8 weeks, third 5 weeks, like the second half of the spring semester. But the Los Rios district isn't committing to anything right now. There's just too much unknown, okay? And I know it's confusing. Like for instance, I'm working with high school students at Natomas High School right now and their auto shop. Those kids are going back into auto shop class a couple days a week starting next week. However, my other school district I work with, San Juan Unified, they're likely not to go back to in-person training until January 5th. So anyways, different school districts are doing it differently. Our school district at Los Rios Community College District, American River College, has decided they don't want to commit to anything that's not online as of yet. We're hopeful that second 8 weeks, third 5 weeks, we'll get some stuff going. But with our online offerings, I wanted to show you what we got going on. There's 2 classes that we haven't ran in a long time. And so one of the good things about this situation for us is we're finally getting those classes going. So there's this class here, AT143, Automotive Parts. I call it the Parts Professional class. We are going to offer this class in the spring, which is something we haven't done in years. And I'm really excited about that. It's all about preparing you for the ASE P2's Parts Specialist certification. So if you want to be that guy or a gal working at the parts store, you can do that. Now, a lot of times you might think, oh, I don't want to just work at AutoZone or O'Reilly's or Napa. if you are a dealership parts person, especially if you move up to be like the parts manager, that's a pretty high end, good wage commanding job. Okay, so the parts industry is pretty big, and you're not necessarily breaking your back the same way you might be as a technician. And you can make good money in doing, being in the parts side of our business. So, I think that's a definite option for a lot of you folks. And I'm excited just because I've wanted to get this class going for like the last 5-6 years, and I haven't had instructors who are willing to commit to help me develop it. And now, because we don't have other options, I was able to turn the screws, and we're going to get this class going. And we should have a couple sections of this class for you in the spring, okay? And again, that's going to line up. If I go to ase.com, that parts class will line up with the ASE P2 parts certification. So you should be able to then, take the class and sign up for the ASE. Where is it? Let me get down to the parts. Okay. Automotive is P2. That's the one we're going to focus on. Yeah, it'll be good stuff. So that's the first class. Second class that we're going to offer that we haven't offered in a long time is the service consultant class, or service advisor. And this class will also be online. It's going to help prepare you for the ASE C1, right? So if I go back here to test series and I go back to service consultant, it's going to help you prepare for this test. But more than that, it's going to help you to prepare you to be a service writer in a shop, whether it's a dealership or independent shop. That's what this class is all about. Now, I do want to say, and I don't necessarily agree with how it is, but this is how it is. I'm seeing a lot of service advisors or service consultants make just as much money, if not more money, than the technicians, the guys and gals actually working on the cars. It is a high stress job. You have to deal with people, and you're trying to keep your technicians happy. You're trying to keep your customers happy, and you're the middle person, right? So you got to manage paperwork. You got to work with people. You got to be a little bit of everything to everybody, and you have to have some technical knowledge too to put it all together. A little bit of bookkeeping skills, all that stuff. This position can pay really well. The other thing that I'm seeing, whereas in years past, you would start as a mechanic, eventually maybe become the shop foreman, and then maybe from there you could become the service manager at a dealership. It seems like more and more the service manager they have someone who starts as a service advisor or service consultant, and they kind of go through the hoops on that. They might even spend a little bit of time on the parts side, and then they become the service manager. And no longer are they looking really to the technician pool for management. They're looking for the service consultant. Why? Because this person, they're good at working with people, and that's what you need to do as a manager. So the 143 class and the 146 classes are ones that we're offering, we'll be offering for sure in the spring. Like I've said, I really would like to get some hands-on classes going, but the district has not committed to anything yet. So the things I've shown you though, these ones are a for sure. Now, if I go to certificates, sorry, let me get there. This probably looks kind of weird to you guys. This is my access for how we look at and view and submit curriculum to the state. Believe it or not, we can't just teach whatever crazy stuff we want. We have to get it approved through the state chancellor's office, and there's all kinds of hoops of stuff you got to go through. Here's all of our different certificates that we offer, and we have a couple that are going through the tech review process to get approved. The Master Auto Technician, these ones in yellow, these would be like if you took every single automotive class we offered, boom, that's what the Master's all about. All right, so what am I looking for? I'm looking for, oh, there it is, parts and service. So because we're offering those two classes that we haven't ran in a long time, and with what a lot of you guys either have already done or in this semester, from AT100 to math, that and data acquisition, that lines you up for getting this certificate during this school year. So at least if you guys who have been kind of stuck in distance learning format, at least through the course of this year, you'll be able to get this parts and service certificate, which may not be what you originally wanted. I totally understand that. However, it's something we haven't offered for a long time, and there is need in the industry for it. So I'm excited that at least we can offer you some type of certificate that we can complete. So that's what's going on, folks, for next semester, spring 2021. That's what we got going on for sure. Like I said, we're constantly negotiating with the district. My hope is like the second half of the spring semester, if the COVID infection rates within our greater Sacramento County area are good. We continue, right now we're in the red zone. If we continue down to the orange zone and stay there, or maybe even get down to the yellow, that will help enable me to convince the district to allow us to run our hands-on classes again. All right, so that's what's going on next semester. Let's jump into what are we doing tonight in our class. Well, through our different presentations, we're kind of like a week behind, which is not a huge deal. But if you look at like, what are we talking about tonight? It's really the week 7 stuff. We're going to go through this no start diagnosis. We're going to go through frequency and pulse width. And I have some different activities I've put together for you here. None of this stuff is due right away, because my concern, although these activities kind of relate to exactly what we're talking about tonight, you know, if this is new for you, you need time to get your meter and mess around with it before maybe you're ready for some of these activities. And so that's why I've put lots of padding time in there that they're not due for several weeks. Okay, but this is the material we're going through. So with that, let me change the screen share, and you know what? We'll start with this one. Some of the advanced functions of your meter. Now, a cheapo meter is not going to be able to do some of this stuff. But if you have a more high-end meter, it should have some of these features. Like if you have that Snap-on 596, if you have a Fluke or something of that variety, you should be able to do some of this stuff. So one of those things is frequency. Now, what is frequency? Well, it's how many cycles do we have going on per second. So it's all about cycles per second. Okay, that's what frequency is going on about. So a lot of times when we think about frequency, we're thinking about sound. Sound, you know, all the different sounds we hear, they run at different frequencies on the audio spectrum, right? Humans, we hear down from like 20 hertz or 20 cycles or times per second, up to about maybe 20,000 hertz if we had really good ears, 20,000 times per second, okay? So 1 hertz is 1 cycle per second. Well, you might be thinking, hey, that's That's great, but what does this have to do with car stuff? So what I want to do is give you a example of how does this relate to car stuff. So to do that, I switched it back to the internet, and I'm going to look at one of these guys. Here is a couple different evap canister purge solenoids. Okay, so there's one there. Here's just the part here. There's one the guy's taking it off there. Here's kind of an outline of where it would be at. So let's talk about this evap canister purge solenoid here real fast. Trying to make that. Let me go to that one. That one's probably a better. Oh, that's not actually what I wanted. I think I like this one better. I just wish this image were bigger. Let's see. We'll do this. We'll zoom in on this screen. There we go. Right on. All right. So what's the purge solenoid do? Well, any of the fuel vapors that are in your tank, right, as you're driving around the road, we're kicking up all kinds of fuel vapors. And our smog laws, we don't just want those wafting up the atmosphere. In fact, if we had that happening, you know, it'd be like throwing fuel out on the ground, right? It would be wasting gas. So not only does this help the car run cleaner, but in theory, it gives you a little bit better fuel economy. And I do believe it helps because, like, my old cars that are open vented, they'll just sit around and, you know, it'll sit for a month, and it went from a full tank to like 3/4 just sitting as that fuel evaporates out of the tank. So the idea is that we trap all these vapors, and later on we burn them in the engine, right? So the vapors leave the fuel tank, they go through some vapor separators and stuff, and they end up going into this charcoal canister. And there, these hydrocarbons, so I'm going to write HC for unburnt fuel vapors, these HCs are stored. Then when we're rolling down the road and the computer determines, I'll put P, oops, that's a PCM for powertrain control module. He decides, hey, everything looks cool. Let's purge these vapors out of this charcoal canister. Well, he's going to do a couple of things on a modern car. He's going to open this up. So he opens up the vent valve, and that allows fresh air from the outside to come in to the canister. And he also then opens up the purge valve. So this guy gets the green light, and he opens up so that these vapors can now go down the line here, go through the purge valve, go into the intake manifold of the engine, and the engine can burn them, okay? And of course, as these vapors are going in, we're gonna then refill this thing with some fresh air and kind of scrub all those hydrocarbons out of the charcoal, and basically use those fuel vapors, right? Keep them from wafting out into atmosphere, okay? But if we just dump this purge valve wide open throttle, it comes on, it could make the engine run lousy, right? If I give it too many fuel vapors, it could make it hesitate, it could make it surge, and people don't want a car that's bucking and surging and running weird, right? That's not acceptable. So what do we have to do? We have to feather this in. We have to control how many of these vapors get into the engine. How do we do that? Well, we do that by turning the purge valve on and off, very, very rapidly. And we control its on time versus its off time to control how much vapors are going to go in the engine. So if we have it on more of the time, then more vapors go in the engine. And we can do that as the engine is turning faster. But when, let's say the engine's idling. Well, if I turn on the purge valve, I could make the engine stall out as I'm sitting there, you know, in the McDonald's drive-thru or something, right? That wouldn't work. So I'm going to keep the purge valve off during those times, and I'm going to gradually turn it on and off. So that type of signal is going to be a digital signal or on-off type signal, and I can vary my on time or my off time based on how much vapors do I want going in the engine at that moment, right? So it's a way for a computer to kind of throttle things by turning stuff on and off, right? It's a digital signal, on, off, on, off, on, off, right? Well, each one of these ons and offs would represent a cycle. In fact, the cycle would be from here to right here. That would be one cycle, okay? So I can measure, if I have a what I'll call a smart meter, right? If I have a really good multimeter that can measure frequency, then it can measure how many of these cycles occur during a second, and then that allows me to see, well, what's the computer commanding here with the purge solenoid? What's going on with that? Now, other types of sensors can make these variable frequency signals as well. Let me give you one other example. I'm going to clear out these drawings, and let's see. And I will go back to here. I should show you a diagram of how it works. Oh, there's a GM diagram right there. So there's a GM evap canister purge solenoid and the vent solenoid. What you can see from this diagram, guys, is that it has power from a fuse, right? That goes to the evap purge valve. And what does the computer control? The computer gives it a pulsating on, off signal to ground. Okay, that's pretty standard. We're usually going to control the ground side of a relay or a solenoid or a fuel injector. We're usually going to control the ground side and not the power side. Okay, it's a little safer for the computer in theory to do it that way. All right, so with that then, that's how that purge solenoid works, and it's going to make a variable frequency as the computer controls the amount of on and off time, right? Let me give you one more example of a component that has a variable frequency. Now, there it is right there. Well, there's a bunch of them here. Here we go. Here's a Ford map sensor. Get an even older one. Well, there's one of the old ones like that. Only 6 left in stock. What year? Looks like some old Broncos there. Anyways, so these Ford map sensors, they didn't vary their voltage. If I look at the, it doesn't show me the connections. Sensor, let's get the circuit up. Hey, look at that, bam. They didn't vary their voltage. They varied their frequency. So here's the wiring diagram. And so it has a 5-volt signal, a 5-volt supply. It's got a ground. This one happens to have intake air temperature. I don't really care about that. But it has this map signal, right? And if you tested with your multimeter on this pin 36 here, this wire right there, you know what? You would get about 2.6 volts. And if you moved the throttle and the engine speed changed, it might change to like 2.5 volts from 2.5 to 2.6. maybe you could almost get 2.7 volts out of it, but it didn't change a hell of a lot. The first time I saw one of these, because I wasn't really a big Ford guy, I wasn't trained necessarily in Fords. I had more of a General Motors training background for fuel injection stuff. I was like, oh, that's why this thing's running like garbage. Something's wrong with the map sensor. It doesn't change the voltage. What I didn't realize, and this is why when you go on All Data or Schottky, it's so important to read like the description of the circuit. Like, how does this work? How does this circuit work? Or look that stuff up on CDX. There's an excellent book. It's been around a long time now called Computer Engine Controls, and it will go into how the different circuits work. But it's really important to know how does stuff works, because then you'll make good decisions on if something's good or bad. This map sensor varied its frequency, not its voltage. Why did the voltage change a little bit? Well, because my meter averages out the readings it gets for their voltages. So you can, if we zoom in on this a little bit more, what you can see here, I guess it won't let me zoom in anymore. What you can see is here, it says amplitude remains the same, but width increases. This is high vacuum, so low frequency signal. This would be at like idle, okay? And this would be at like wide open throttle, okay? Well, because this one is on more often, the voltage would go up very slightly. And because this one is off more often, the voltage would go down a little bit. But I was looking at the wrong thing, and that's why I misdiagnosed the first one of these I came across, because I was looking for it to vary voltage, and it didn't work that way. It varied frequency by the change in manifold vacuum or pressure, okay? So you can see at 0 inches of vacuum, or about 15 psi atmospheric pressure in there, it has 160 hertz, and it drops down to somewhere around 80 or 90 hertz at idle. So as you get further into this stuff, having a meter that can do other tests like frequency becomes important, right? So now that we kind of got the backstory on all that, like, a couple examples of why that might be useful, let's go back to our presentation. Here it is. So frequency, number of cycles per second, right? Cycles per second. All right. So with that, got a couple other things here. Okay, so a megahertz is 1,000,000 times per second in frequency speak. So, all right. How does it look on a lab scope? Remember, a lab scope's like a fancy meter in that it samples the signal a lot more quickly. It also draws what it is measuring. So it's just displaying numbers. It actually draws it out on the screen, okay? In fact, in the 90s, when lab scopes first started to become popular for automotive work, I tried to get one. Well, first I got access to one early on, and I learned a lot from a lab scope. In fact, that map sensor, I probably, how I figured out I had screwed up. Well, my first thing that I figured out is I bought a new map sensor and we put it on there, and guess what? It didn't fix the problem. So like, obviously that we did something wrong, but then we were like, well, what the heck's going on? I don't know. My boss was also a GM guy, so he was thinking about it the same way I was, and we were both missing the boat. So what we ended up doing, though, is he had a fluke scope that was really for electronics industry, but we hooked up the fluke scope and we saw a signal on it that looked like what you guys see on this box right here with the up and down shapes. And then we were like, oh, this is different. This works off of frequency, because back in those days, we didn't have All Data at that shop. We didn't have Mitchell on Demand. all data had just come out, and you had to put like CDs in the CD-ROM, and we had manuals on the wall. And oftentimes a car would come in, and guess what? We didn't have a manual for it, or the section of that manual was gone. I mean, it was really like you were in the woods trying to figure stuff out. We put the scope on there, and we were able to kind of figure out how it works. So one thing that I always liked about oscilloscopes is because you could see what the voltage was doing over time, because it would draw it out on the screen. You could kind of figure out how is stuff supposed to work. Okay, so I learned a lot using a scope. Anyways, so what would frequency look like on a scope? It would look just like this. It's that on and off square wave signal. And then as the frequency would increase, the square waves get closer together. And as the frequency decreases, they get further apart, right? So follow the trace up, across, down, over. So up, across, down, over. And of course, no matter where I put these little chat boxes and stuff, they're always in the way. Up, across, down, over. That is one cycle, okay? Here are the drawings. Change the tool, okay. Boom. Okay, number of cycles per second is the frequency, right? So if we're doing 100 hertz, that means the frequency is changed 100 times in a second. Has anybody in our class, have you used your meter to measure AC voltage? Has anybody in here done that, where you've used your meter to measure AC voltage? You could raise your hand, you could, I don't know, put something in the chat. I can get the chat back up. So if you do that, if you're measuring AC from your house, right, with your meter, you put the leads in there, measured AC, and it says 120 volts or whatever it would say from a normal outlet. It is changing its frequency at 60 times per second, or 60 hertz. So our electricity from the power company coming from Folsom Dam, right, is coming in at a frequency of 60 hertz. And that 60 cycles per second, that's actually how every, like if you have a clock that you plug in the wall that's digital, it's actually using that 60 hertz to measure time. It counts those 60 cycles per second and goes, okay, that was 1 second. And it keeps counting that up, and that's how it gets to a minute and an hour and everything else. So it is really important for the power companies to maintain a perfect frequency of 60 cycles per second. Anyways, how do we actually measure it? Well, if we had a fluke 87 or 88 or a fluke meter, we would just put it on voltage there, okay? And you can see it's got these dashed numbers and stuff. We would put it on voltage, and then we would press the frequency button right here, and then it would switch over to displaying frequency. So here we got something, and it's displaying 157.74 or so hertz. In fact, it has a little HZ that comes up on the screen there, okay? So that's how you measure it. And of course, then you might change the speed of the engine, or as you drive it on down the road, you're testing the canister purge, and you're seeing how that frequency is changing, okay? So that's frequency. Now, there's a different term that's, I mean, these things are really related, but they're a little bit different too. And that is duty cycle. Duty cycle is a comparison of the on time to the off time. So we're comparing the on time here to the off time, and that ratio is your duty cycle, if you will. So on time to off time. So sometimes what happens is we might have a signal that it's not varying the frequency. It might be on a fixed frequency of, let's say, I don't know, 10 cycles per second, fixed frequency. but it's going to vary the on time within that fixed frequency, or it's going to vary the duty cycle. So where the Ford map sensor varied its frequency, actually, if I was going to test a canister purge valve, duty cycle for most vehicles would be a better measurement for me to take. So what do I do here? Well, I have it. I can select the right thing. I have it set for volts. I hit the same button again, because if you look at it, I have it set to volts. I hit it one time and it's selected frequency. I hit it again, and now it's the percentage for duty cycle. So I hit that little button twice on this particular meter, and then when I do that, the screen changes and it tells me, okay, I'm at a 50% duty cycle. And then I could change the speed of the engine or do whatever I wanted to do, and I could see how that duty cycle changes. So let's say you're testing something and you're like, I don't know if this thing's going to vary frequency or if it's going to vary duty cycle. Well, just try them both, right? Change the speed of the engine, change stuff around, and see, does the frequency change? Nope. Hit the button again and see, does the duty cycle change? And oftentimes what you can do is, if you had a scanner on a car, you can compare what the duty cycle or frequency set on the scanner versus what you actually measure with your meter to diagnose what the heck's going on, okay? So we got one more on here that's still related. It's pulse width. Now, pulse width is a direct measurement of the on time, meaning that we're looking at the actual amount of time that the signal is on. This time right down here. Now you're probably thinking, well, wait a minute. If this is, let's say this is 5 volts here, and this is like 0 volts here, why are we saying that it's on when it's down low? Well, if you remember the diagram that I showed you before, where you had a computer, inside that computer magic box, it had a computer driver circuit, which was a switch, and the switch controlled the ground side. The wiring then went from there, it went to, I'll make the solenoid here green, and here's my windings of my solenoid. Boom. And of course, we had our 12 volts. It's supposed to be a 12 volts of power. Oh, that's terrible. I can't. We got to redo that. Eraser. Having a bad night for Zoom tools. We got our 12 volts coming in. So the computer controls the ground side of this thing. It's giving us that pulsating on and off ground control. So anyways, when the circuit is turned on, right, when the switch is closed, if I'm measuring my signal, say this is my yellow fluke meter, and I'm measuring the signal between there and ground, that's why it's going to be low when it's on. Okay, that's pretty standard. Okay, so what is pulse width? It's a direct measurement of this on time, which is when the signal is low. Okay, obviously that varies as the duty cycle changes, and it's typically measured for computer stuff, because computers operate pretty quickly. It's measured in milliseconds. So I got to clear out all these scribbles. So what do I do now? I hit the button, the same stupid button. I know, you're like, what the heck? I'm going to hit this button a third time. And you see how we got the MS right here? We hit it again and we get that milliseconds up on the screen. And then we do that, and we get our pulse width, or our time that the signal is actually on, measured in milliseconds. So different ways to look at the signal. For instance, if I'm measuring fuel injectors, what I will then measure, what I like to measure for injectors, is pulse width, because it gives me a physical amount of, this is how much the injector's on. As I romped on the throttle, I expect that pulse width to get larger. So a common pulse width for a port fuel injected car might be, maybe around 4 to 5 milliseconds at idle. If I romp on the throttle, I do a snap throttle, it's going to jump up to 16 to 20 milliseconds and then stabilize back down. Okay, so those are some of the advanced features and things that you could test with a more high-end meter. Frequency, duty cycle, pulse width. A lot of meters will do RPM and all kinds of other whiz-bang stuff, dwell. And so that would be some of the advantages of having the really expensive type of meter. It gives you more tests that you can do, okay? That being said, 99.9% of the time, well, maybe not that much, but at least 90% of the time, you know what we're doing? We're doing basic testing. We are measuring voltage, resistance, or maybe current flow. So we will now run through this no start here, and we'll be doing some advanced meter stuff, but essentially that's what we're doing. Okay, now wait, I gotta make sure that this screen share is working correctly. Vehicle case study. There we go. I had a problem earlier where I was trying to share the screen and it wasn't advancing the slides I wanted correctly. So, okay, so no start, but it cranks okay. We have a 2000 GM van. So those actually won't be that much different than some of Victor's post office trucks, really. Cranks, but no start. What should we test and how? You guys tell me, and this is not just limited to like using your multimeter. What are some things that you would want to test?
The fuel
what do you guys think? Yeah, the fuel pump. Yeah, exactly. Now, I think what I would do first is I need a direction, right? I call it, I need to establish a condition, right? So how do I establish a condition? Well, an engine needs three things to run. It needs heat, fuel, and air, okay? It gets heat from spark at the spark plugs and compression in the engine. It gets fuel from its fuel injection system or carburetor, whatever. And of course, hopefully it has air going into the engine, but I have seen it where a rat built the nest in the air filter and it literally could not bring in any air in the engine. So that is an option sometimes. So what I would do is I would squirt some carburetor cleaner or starting fluid, something like that, down the intake of the car, and I would crank it over. And if it fired up and ran for a second, I would know, hey, I have a fuel problem, right? But if I squirted a bunch of starting fluid down the intake, or carburetor cleaner would work, and the thing doesn't even try to start, then I start thinking, oh, well, the problem's not fuel, maybe I have no spark. If it cranks over weird, it cranks over erratically, then I'm thinking, hey, maybe I got some type of a compression problem, right? But in this case, we'll say we gave it the starting fluid, thing fired up for a second. So that pointed us in the fuel direction, and that's where we're gonna go. So let's measure the fuel pump pressure. Well, guess what? We don't have any, okay? Here's our fuel pump pressure gauge. So I know we're using more tools than a multimeter, but in the real world, you're not just gonna be using your multimeter, right? That's one tool in your toolbox. Remember, your most important tool is what's between your ears, right? That's your most important tool. And then it's from there, figuring out what other tools you need to use to figure this thing out. So it's a no start. It's got no fuel pressure. We know it's fuel delivery related. And what we're circling there is the fuel pump relay. So moving right along. This is the circuit for the fuel pump relay. Okay, it is controlled on the power side of the circuit, not the ground side. So remember I told you how normally we're controlling stuff on the ground side? I got an oddball for you. We're actually controlling this dude on the power side, which I know seems like super weird, but that's, you know, stuff doesn't always fit perfectly within the box. But all right, so you can see fuel pump fuse. There it is right there, 15 amps on the diagram. That's how it would switch through the relay. Doing that wrong, it would go from there to there. When the relay turns on, it sends power down to the gray wire. The fuel pump relay control is actually on the power side. Okay, so hey, is it important to get a diagram? It absolutely is important to get a diagram. Almost all the activities I loaded up for you guys to do with your meters, the first thing it says is, hey, go get a diagram, right? The diagram can help us teach us how does the circuit work, okay? Diagram, and then if you can't figure out how it works by just looking at the diagram, then you look up the circuit description, okay? All right, so here's the relay connector detail, and guess what? It's like any standard Bosch ISO relay, pins 87, 87A, 85 and 86, and of course 85 and 86 are our control circuit, power and ground. We're going to control the power on pin 86 to this, and of course then our switch circuit is going between 87 and 30. Okay, pretty standard relay terminal configuration. All right, clear that out of there. So then the question is what pin would we need to supply voltage to activate the relay? Yeah, I need your help here. What pin would I need to supply voltage to get the relay to turn on, you know, if the relay's good, right? What do you guys think? Well, I already told you the computer controls the power side, not the ground side. So which one of these is the control for the power side?
Is it 30 and 85?
It's 86 here is good deal. 86, I got 85, 86 in the chat. So 85 is the ground. The grounds on this particular one's always going to ground, so I'll draw that if I can. There we go. So this pin's always going to ground, and on this case, what the computer does is he actually provides power, 12 volts, to pin 86 to turn on the relay. So that means if I put power, I backprobed it, put power 12 volts to 86, the relay should turn on, okay? Okay, so let's see if we can do that. There we go. All right. Well, what pins would we need to bypass the relay? Let's say we said that the heck with that, trying to get the relay to work. What if I just wanted to bypass it? I wanted to take a jumper wire, and I wanted to use my jumper wire and bypass the relay directly. What terminals could I jumper together?
85, 86?
No, that's the control.
I mean, 87.
87 to 30, right? Boom. So if I took a jumper wire, and ideally I would use a fused jumper wire, is what I should tell you as your instructor, although we often leave caution to the wind. I would jumper those two together. That should bypass the relay and turn on the fuel pump, okay? Let's see, I can't, if Tom is here tonight, yeah, he was asking me about the power probe. If I was power probing it, I would have put power right there to pin 30 and see if that turned the fuel pump on. All right. Let's clear out those drawings. Let's get the mouse back up. And boom, look at that. Okay, so now let me take 2 steps back. You know what I would have done before monkeying around with all that stuff? Once I realized I had no fuel pressure, maybe even before I knew how the circuit worked, once I identified the fuel pump relay, I probably would have switched another relay in a spot, right? Just because that's easy and fast. I would have taken the horn relay, some other relay that was the same type of relay, and I would have thrown it in that spot and see if that made it work, right? Because a bad relay is a relatively common situation, okay? Also, so is a bad fuel pump, by the way. In fact, the bad fuel pump, the defective fuel pump really is probably more common, but relays are something that they do, you know, take a dump from time to time and quit working. So I probably would have done a quick relay switch. Let's say we did that, it didn't make it work. Here, what we've done is we've bypassed the relay altogether with the jumper wire. Uh-oh, it's not fused. You guys didn't see that though. We bypassed the relay with the jumper wire, and look at this. I now have 55 pounds fuel pressure. So, hey, the fuel pump's good. The fuel pump's working, right? The heck's going on here? In fact, what we have right here is an amps clamp going to a low amps probe so we can monitor how many amps are actually flowing through the fuel pump. And I can't remember if I got a picture of that. Oh, yeah, I do. Remember that the low amps probe changes the magnetic field it measures, turns it into a voltage signal. I know that's a little confusing. This thing set the volts, but really with this probe on there, it is measuring amps running through this wire. It's picking that up. So this 0.514 amps, or 0.514 volts, that's really 5.14 amps, okay? It's pulling 5 amps, basically, which is a pretty normal amount of current draw from a fuel pump. They're anywhere from maybe a low of 4 to a high of like 8 amps or so. So he's right in the middle. So I'm gonna say, hey, the fuel pump current draw looks good, and I can see the fuel pump's providing adequate pressure if I could just get the darn relay to work, right? So now I'm starting to pinpoint, not only do I have a direction, I'm starting to pinpoint the problem. Now, could I have, if let's say I didn't have this $100 amps clamp thing, could I have just put my meter in, put the probe in the amps spot and put my meter in series with the circuit and have the current flow through there? Yeah, I could have, and my meter would have measured 5 amps, right? So anyways, I didn't have to use the low amps probe. It's a little safer for our meter, but it would have worked the other way. Okay. So if the question is, if the fuel pump runs when we activate or jump the relay, where's the problem? Okay, and let's say we also manually activated the relay by providing power to pin 86, and the relay turned on and we had fuel pump pressure. So what is the problem in our relay?
Switch, the switch.
No, it's maybe the switch. Well, remember the switch here is not just a switch. It's the computer supplies power to the relay. So let me turn this on to you. So what we suspect is that the computer, get my controls out of the way, the computer is not sending a pump priming signal, a pump signal, a signal that says, hey, relay, turn on the dang fuel pump. It's what we suspect is it's not providing that signal to the relay. And that's preventing the pump from running. So here we have an LED on the relay pins, 85 to 86, and you can see, oh, the LED turns on. Okay. So then you say, oh, wait, it looks like a bad relay. But wait a minute. I manually activated the relay, and it worked. And in fact, just because, you know, I like putting new parts on cars, I put a new stupid relay in there. And guess what? It doesn't work with a new relay. It's more than a new relay. But wait a minute. I put that little LED light in there. Now, LED, guys, for those of you who don't know, it stands for light emitting diode. Light emitting diode. And those light emitting diodes, they don't take very much current to make them work, okay? They're somewhat computer safe, you could say. So, LED works, but guess what? It ain't a relay. So, what's going on now? We back probed it, you can see that, and we ran a jumper wire all the way over to pin 86 on the computer. So we went from there, and we run the wire, and we start measuring its resistance, and we actually figure out, here's the PCM and the wiring diagram, there's the pin we want, and we go right there, and you know what, we start probing around, and at first we're measuring I said we're measuring resistance. We're measuring resistance by looking at voltage drop. So between back probing at the computer and this pin right here, we're measuring a 1.838 volt voltage drop. That's way too much for a computer circuit. I really don't want more than like 0.5, okay? So we're measuring a pretty substantial voltage drop across the circuit, meaning that there's some resistance in the wiring of this circuit, right? Between here at the PCM and over here at the fuel pump relay in the underhood fuse box. There's the pin. We start digging around, messing around, clamping, and all of a sudden, wait a minute. Now we're getting full power here, and the van started. What the heck's going on? We start wiggling stuff around, and actually Ford, this was an official test for Ford, okay? They called it the wiggle test. You start wiggling the wire harness around to see if there was any bad electrical connections, okay? And don't be mad at this young lady here who is working on the car. You know, she's wearing some rings and stuff. No, she should not be wearing that, so she is in trouble. But anyways, so now it started for a minute, now it died, and this is what we found, actually a bad connection at that tiny little pin that plugs into the computer, okay? And so we did that by really some basic tests with measuring voltage drop, using jumper wires, that type of thing, okay? Now these little pins are repairable. You can get terminal kits and actually go in there and repin this thing out. It's kind of a pain in the butt process. You got to have the special terminal tools, but you can do an excellent job with the right tools and right pin kit of fixing that up really nicely, okay? So put it all back together, has full power with the wire harness repair, and it works. Now, I have here test dynamically. What do I mean by that? Well, remember we put that little LED probe on there? Well, the LED probe, it doesn't take a lot of current to make the LED turn on. In fact, the LED probe then is considered to be a low current light. And I have here, it's really only an indicator, okay? Remember that voltage drops only happen when you have enough current flowing through the circuit. So to really test circuits, sometimes you actually have to load the circuit to accurately determine whether or not it works. So sometimes you got to use dummy loads or actual components. So in this case, because we only used a clear out these lines. Because we used this LED instead of like a regular test light, we didn't see that had a bad connection there, that there was too much voltage drop there. And so it kind of threw us astray and caused us to replace a relay we didn't really need to replace. Now, that's not that bad. It's not the end of the world. It's not like we threw a $500 computer on there. But we did replace a part that didn't necessarily need to be replaced. However, we were thrown astray because we forgot that this LED doesn't take hardly any current to make it operate. Neither does your meter. Your meter can measure voltage and not see a resistance issue because there's not enough current flowing through the circuit. So remember, the lesson here is to be smart enough to test dynamically. So to show you the difference of dynamic testing versus kind of static testing, I got the document camera out. Now, we have good old-fashioned 12-volt test light right here, okay? And that test light is going to pull some current flow, and so it would actually flow about the same amount of amps that you would need to actually run a relay, okay? Let me show you what I mean. In that this this wire here is connected to my positive battery terminal. The ground wire of the test light is connected to ground, and if I hook this to this, the test light turns on, right? Well, I'm going to use this. I'm going to use this nice snap-on meter here to actually measure how many amps are flowing through that circuit. Now, I've selected amps. What do I need to do next to actually measure how many amps flow through my test light? What do I got to do? You guys tell me. What I got to do to test how many amps are flowing through that circuit? Do I put this guy in series with the circuit or in parallel? Not everybody at once now. I've stumped you. You might be seeing on the chat, and I can't see the chat window right now. So, so the answer here is series. We got to be in series with the circuit, and we got to move our leads. So I'm going to move this lead over to measure amps. I'm going to take this probe, and I'm going to hook it to my power wire coming from the positive battery terminal. Okay. So, and this wire here is going to hook to my light. And now the current's going to actually flow through my meter to my light. Okay. And you can see it's taken 0.07, 0.08 amps. I'm down in the milliamp scale. So I'm going to go down to the milliamp scale. And I'm going to do one other thing. I'm going to reverse my polarity here just because it'll make it easier for my leads to clip on. And as I told you before, I don't really care if there's a plus or a minus up on my meter screen. I just want to see that I got numbers there. So here we go. The minus is up there because I reversed the polarity, but the way I had alligator clips, it made it more handy for me to do so. I am flowing 160 milliamps through that test light, okay? So a test light, in order to illuminate this little tiny light bulb in here, it's gonna take 160 milliamps, okay? LED might only take like 10 or 15 milliamps. So if I would have put my test light on that relay driver circuit, it would not have turned on, okay? Because I couldn't pull the amps through it that I needed. Now you could do the math on this if you wanted to. Like you could say, all right, well, 160 milliamps is 0.160 amps. So if I had 12 volts and I divided that by, okay, that means that relay, or that means this test light, when it's hot and it's on and it's glowing, has an internal resistance value of about 75 ohms. I just figured that out using Ohm's law. Well, guess what? If you measured the resistance of a typical relay, it's somewhere between 60 to maybe 85 ohms. So this is a pretty good simulator for an actual relay. Now, let me do one other test. Let's say I just took my meter by itself and I tested that pin and I wanted to see, well, do I have power at that pin? So here I'm going to take the Harbor Freight meter here. And the Harbor Freight meter, I'm going to hook him to power. There we go. Is that basically, I have next to nothing. When my meter is set to measure voltage, we talk about these meters having a high amount of internal impedance or internal resistance. Their resistance is so high, they don't flow very much current. So in the case study, I used we used a LED that didn't flow a lot of current. Well, your meter doesn't flow a lot of current either. And so when we talked about using dummy loads and really trying to test the circuit dynamically, the test light would test it dynamically to put some load on the circuit, okay? So remember, I've said this a bunch of times before, but electrical circuits, it's the current that makes the circuit work, right? It's all about the current flow through the circuit. That's what actually makes things work, is little electrons flowing through those wires and through those components. So whenever you can, test dynamically, and that will help you go in the right direction. So, so that was our nose start diagnosis, and just trying to show you some different ways that you could test using your meter and a variety of other tools. Remember that the meter really is one tool in your diagnostic toolbox, and it's a tool there that's really set up for pinpoint electrical testing, right? So you can't do everything with it, but you can certainly do a lot. All right, so that's what I had for you for tonight. Let's talk about next week and what's going on in the class. We're going to skip next week. That means that we're not going to be online for a Zoom session next week. We will come back in week 9 to so I can give you an overview of all the Snap-on stuff and how the rest of the class is going to work. Okay. So at this point, you know, we've talked about how to use your meter for different tests, everything from how do you measure voltage and current and resistance to measuring frequency and duty cycle and stuff like that tonight. I've shown you some different case studies that had technicians using their meter for electrical diagnostics, and then different ways you could use the meter, even with different options like current probes and stuff like that. I have some handouts loaded into the class that are all about doing wiring repair and trailer wiring and different presentations on that type of stuff for you. So there's all kinds of resources. And so part of us not having a Zoom next week is to kind of give you guys a chance to kind of catch up on all that stuff and mess around and look that stuff over. Each week I did load on like what assignments kind of lined up with what we were talking about. So for instance, I do have a, well, we have a little quiz here that's on electrical circuit knowledge. Now, it's not a million questions. It's only 5 questions, but it's kind of stuff that like we talked about tonight. Like I just said this, what does the work in the circuit, right? You guys tell me, is it the ohms that does the work? Is it Ohm's law? No, it's the current flow, right? It's the current flow in the circuit that does the work. So these are in there because they line up with what we were talking about. However, if you look at this guy, he is not due until, end of November. So I don't want you to feel stressed out that anything is due like tomorrow, right away. There's not, we do have some stuff coming up, but these things like we just talked about, I want to give your brain time to process all this stuff, right? And again, with this class, like all the others, I will take the recording, make the Zoom recording, and get it posted so that you could watch it over again if you wanted to. How do we know what's coming up? Well, we go over here to the calendar. Let's try that again. We go over here to the calendar. Oh, I know what's going on. It's trying to activate my document camera controls. Again, too much stuff on the screen. Now it's thinking about it. Okay, and we are here, we're on the 15th. So we do have charging and starting system diagnostics. And we were talking about this a few weeks ago. So what do I want you to do with this activity? Well, you're basically going to hook up your meter, and it could be, just the inexpensive Harbor Freight or, $5 off an Amazon meter. Doesn't have to be anything elaborate. And all you're basically doing is measuring battery voltage while you crank over the car, and then you start it up and see what the charging system voltage is. So we actually did that for you in one of our other case study things. If I go back to our class, so that's what's coming up due for you guys, is getting you to take your meter and go out and do a test. Now, if you're like, man, I don't know, I don't want to do that test. I'm scared to do it, or I don't have a car, or whatever. It's okay. Remember, you can get your points a bunch of different ways. There's enough extra credit in the class that if you skip that assignment, it's not like it would kill you. Okay, but I do think you'll learn something from the assignment. In fact, if I go back to our class, I'm going to go to Studio here, and it has a whole bunch of the videos that we've done for class. And I showed you this a few weeks ago. I don't know why it looks so weird on this screen.
Here we are with the RX-7 race car, and we're going to use it.
So I'm going to turn off my own voice so I'm not talking over myself. But you're going to do the exact same thing that I do right here. I've hooked up the little Harbor Freight meter to the battery. I'm measuring the state of charge right now. I'm going to crank it over, and I'm going to see what the battery voltage drops down to. Okay, that's the available voltage. Then I'm going to keep that meter hooked up to the same spot, and I'm going to start it up, and I'm going to see what the voltage goes up to. Okay, and in fact, you can compare what happens on your car to what happens on this RX-7, and that can kind of help you figure out what was going on with that RX-7 if you missed that presentation. So that's the assignment that's due next. Another way you could look at what's due next, if you don't like using the calendar, is you could just go here, you could click assignments, you can scroll through this stuff, and you can see, okay, what's coming up next? Let me look at all these due dates. Oh, the starting and charging diagnostics. There it is. click it, and it takes you right back to this deal. And essentially what you're going to do is you're just going to use your cell phone or a digital camera. And what I recommend is you take your cell phone, you put the Canvas app on there, and that should allow you to submit it directly from your phone to the class. But you're just going to do 2 little tiny short videos. One is your state of charge and your available cranking voltage, and the other is your voltage output, voltage regulator testing your charging system. And it's just measuring battery voltage and firing this thing up and seeing what happens. So it's 2 pretty easy activities. Again, if you're nervous about doing those on your own car, you could skip it. I made the video. You could watch my video and go through it that way. There's a ton of extra credit available. In fact, if I go back to that assignments deal, you can see that not only do we have all the Zoom points, the whole Snap-on things, extra credit, there's all kinds of stuff for you. So, so that's what's coming up next. We will have some discussions a few weeks after that. In fact, the one on the RX-7 diagnostics up in a few weeks. The idea with it is that first you would do some charging and starting on your own car to kind of figure out a baseline. I'm assuming there's nothing wrong with your car. And then you can compare it to what I got on the race car, and it should help you figure out what was wrong with that car if you missed that presentation. I have one other one I'm still putting together on the Formula V. We used it in class for a few weeks ago. I'm going to have a diagnostic activity on that thing. And then I also have another one I'm putting together, and that's why it's grayed out. That will be on using an advanced meter like a Fluke or the Snap-on to do some of these things like duty cycle and pulse width and some of the stuff I talked about tonight. Just some stuff where you see me do those on a video and how that works. And I'm going to ask you just a few questions about it. So anyways, that's all the stuff there. You can see there's a few of these things I'm still working on. So no class next week. When we come back the week after, what we will do is work on the week 9 info. And I'm going to start laying out how everything, all like the Snap-on specific stuff will work out, and all those video clips and different things that I've made for you. We'll also do some review when we come back on the on what is kind of considered the final exam of our basic electrical circuit and meter knowledge. Remember, this thing's not due till the end of the semester. It kind of lines up with all of our information, so I stuck it there. And I know some of you guys have had electrical. You might be itching to get this thing wrapped up really quickly. So you might want to jump into that thing and do it right away. But if this is new to you, put that thing off. Spend the time to go through the Snap-on stuff. Spend the time to review the materials, do some tests on your car and stuff. And then when you're ready, take that test. Okay?
There's no pretest?
What's that?
There's no pretest for that final?
There's no pretest, but what I do need to do is I was going to give you a couple chances to do it. So I'm going to give you a couple times that you could take it. I need to make sure. Where did it go? Time limit, shuffle.
Allow multiple
Right.
attempts.
Where, oh, yeah, there it is. Thank you. Okay. So we're going to give you a couple attempts on that thing.
2? Oh my God.
Well, hey, man, all you need is once, right? You're going to nail it the first time. But yeah, take it. Look, remember, it's open book, guys, right? Like open internet, open Google, open, you know, you can download all the presentations. Like it's open everything. And I'm a big believer in that, because I think working on cars is way the hell too complicated to know everything in your head, right? what you need to be able to do is know how to look up the information, learn what you need to in the moment, and get the job done, right? So this thing's open so that the idea is that you do that. Now, I don't want you to take it 50 times and just randomly guess on crap, and then eventually you got a good grade because you guessed right the 50th time. I want you to try it once, kind of get a feel for it, look up your answers as you go. So that's why you have a couple attempts and everything's open for you. Again, this thing's worth 50 points, but you could also do the snap-on stuff that's for extra credit that's also worth 50 points. So if you didn't want to do this, you could skip it because it's all how the points add up. It's not like it's a super complicated deal. So I wrote on here that Snap-on and the Zoom sessions, we've actually done more than 5, and I've even added extra things that I didn't initially have on this chart that all count as extra. So this will be a really easy class. Like you could even mix and match of what activities you wanted to do. Obviously,
so
if you do all the
test?
So the Snap-on test is a certification on Snap-on NC3's website.
You gotta
So
pay
if
for
I
it?
went all down here to week 16, I've broken down all the Snap-on factory information into a bunch of different videos and PowerPoints that I put together. The idea is when you got through all that stuff and you felt like you kind of understood how that Snap-on meter worked, I do have a pre-test for that. Let me get that added. There it is.
Oh, nice.
So because with the Snap-on, like you only get 3 attempts. There's no way for me to reset it. Like that's it, man. So we put together a pre-test for this. To do your final NC3 certification, you actually go to a different website. You go to nc3certs.com and you put in your school email, and your password is password1, and you test on the Snap-on website. And that test is difficult. It's tricky. They are very specific on how that meter works. And what's more difficult for you guys this semester is normally, we would have been in class and everybody would have been handed a Snap-on meter and you would have been running these meters through their paces all semester, all right? So now you're trying to do this remotely. So that's why I made my own final for you that's a bit more like basic meter knowledge, and I made the Snap-on stuff as extra credit, okay? So like you guys can, you can do the class kind of how you want to do it, how you can get the most from it. Ultimately, you need what the 250 points or whatever to ace the class. That's the top. If you get over that, or you got that or more, you have an A. And you can do it however you want. If you do all the activities that I put together, obviously not only will you get an A, more than an A, you get like over 100%, but you would obviously learn the most amount from the class. So no class next week. We will come back for week 9, if you will, and I'll go through all the Snap-on stuff in more detail than I've done just now, obviously. So I'll go over all that stuff, how it works, answer your questions, and we'll kind of wrap this thing together. So at that point, after that Zoom session, I can kind of send you guys off on your own to wrap this course up, okay? Remember, it's only a 1-unit class. I already feel like I've given you 15 units of information here, so I'm really trying not to kill you. I want to give you the information, and then you guys can do what you want with that. So hopefully that makes sense, and you're getting something out of this thing. I really encourage you, if you feel comfortable and you have your meter, go do those on-the-car tests, okay? I'm not asking you to do any tests that really require you to get like underneath your dash or underneath your car or in weird spots or putting yourself in precarious situations. I'm trying to just ask you to do pretty simple, straightforward things that will kind of solidify the basic tests with our meter. But just like I showed you in the diagnostic case study tonight with the nose start on that General Motors van, that Chevy van, a lot of the high-end diagnostics is just doing the basics really well, really understanding those basics. Because I'll tell you, I've been at a lot of shops where that van would have got a new fuel pump, a new relay, a new computer, and then they would have been scratching their head and probably would have kicked it to another shop, and they would have figured out that you had a bad crimp connection at the wiring harness at the computer. Okay?
That's what we do at the
but
post office.
I see that stuff all the time, man. Like they just, you know, and it's part of it's kind of part of who we are. It's kind of part of the fault of our industry pays us to put parts on cars, right? Like, and so, you know, it's all built on that. But I've seen way too many parts thrown at cars that didn't need those parts because they weren't properly diagnosed. And it really just required basic diagnostics, just like you saw tonight, step by step by step, and really thinking about how it works. So I hope that helps you get going. Remember, test dynamically. It's the current in the circuit that does the work, and you'll be well on your way to doing some good diagnostics. No class next week. We'll come back the week after that and wrap everything up. With that, I'll let you guys get back to your nights because we've gone a half hour over time, and I don't want to take you any more of your time than we have to.
Is that
Okay?
extra credit?
You being here tonight and following along gets you extra credit. Confer Zoom does an attendance report for me so I can see who was here. It's really cool. I do need to go in and update grades. I do need to go in there and update grades. I haven't had a chance to do that. I'll be working on that next week as we have that time away. So I have a chance for myself to get caught up on this class as well. So you guys have a great weekend. Have a great week next week. And a happy Halloween and everything. And then we'll, no, I'll see you right before Halloween. That's right. Next week is like the 25th or so, 22nd. So have a great next week. We'll come back. We'll see each other one more time right before Halloween. So.
Okay, thank you. Good night.
Have a good one, guys.
All right.
Good night.
Later.